Welcome to Fractional Index video, a unit in indices and log. First, we have to understand some basic concepts. Given an equation, 9 raised to 1/2 times raised to 1/2, using multiplication rule, you have the same basis. So you will add the exponent. So 1/2 plus 1/2 will give you 1. So it's going to be 9 to the first power, or simply 9. Okay. Now by looking at this, we can tell that 9 raised to 1/2 is equal to the square root of 9, which is 3. Okay. So rewriting this, we can write it as square root of 9 times square root of 9, which will give you square root of 9 is 3 times square root of 9 is 3 is equal to 9. So you can see that the 9 here is the same as the 9 above. Okay. Another example. 8 raised to 1/3 times 8 raised to 1/3 times 8 raised to 1/3. Okay, we have the same basis, so if we add the exponents, okay, 1/3 plus 1/3 plus 1/3 is equal to 3 out of 3, or 3 over 3, which is 1. So to simplify or to evaluate, it's 8. So we're using multiplication rule in our indices law. Okay. We can also write that as 8 raised to 1/3 is the same as cube root of 8, which is 2. So that means that if you multiply 2 to itself 3 times, you will get 8. So I'm rewriting this. So 8 to 1/3 raised to 1/3 is the same as square root of cube root of 8 times cube root of 8 times cube root of 8 will give you 2 times 2 times 2 equals 8. You will see then that you get the same answer as what you have here on top. Okay. The last example for this, to understand this concept, as we are going to make a general rule for this, if we have 16 raised to 1/4 times 16 raised to 1/4 times 16 to 1/4 times 16 raised to 1/4, if we add all the indices or exponents, 1/4 plus 1/4 plus 1/4 plus 1/4, you will have 1, or 4 out of 4. So you will have 16. We are using multiplication rule. If we're going to rewrite 16 raised to 1/4, it can be rewritten as 16 raised to 1/4 is equal to 4th root of 16. This means that if you multiply 2 to itself 4 times, 2 times 2 times 2 times 2, it will give you 16. So let's rewrite this. 4th root of 16 times 4th root of 16 times 4th root of 16 times 4th root of 16 is the same as or equal to 2 times 2 times 2 times 2, which is equal to 16. This 16 is the same as the 16 above. Okay, so in general, we can have a rule, and this rule is a raised to 1 over n is the same as the nth root of a. Now, take notice that the denominator of your index or exponent is going to be the root if you use the radical sign. The radical sign I'm talking about is this sign here. Okay, let's move on and let's have some questions. Write in radical or surd form. I'm using 2 words here. Okay, and then I'm going to put here and show you our general rule, which says the nth root of a is equal to a raised to 1 over n. By following this general rule, let's write these in radical or surd form. Let's take a look at 4 raised to 1/2. Following this rule, we can write this as square root of 4 But you can still simplify this because you do not need to write the 2. This is the same as square root of 2 without the 2, because by default, if you don't see a number here, it means 2. Okay, it means square root. Okay, now you can pause this video and then write everything else in radical and surd form. When you are ready, press the play button again and see if your answers are correct. Okay, moving on. 27 to raise to 1/3 is this in radical form. 125 raised to 1/3 is cube root of 125. And 81 raised to 1/4 is fourth root of 81. And 32 raised to 1/5 is fifth root of 32. Now, let's extend this learning by evaluating the values. Let's evaluate them. Square root of 4 is 2. Cube root of 27 is 3 because 3 times 2, 3 times is going to be 27. 3 times 3 times 3. For the third one, cube root of 125, to evaluate, it's 5. Fourth root of 81 is 3. And fifth root of 32 is 2. Okay. Let's study one more concept. Let's write these questions first, or numbers, into index form. Remember that index is the same as exponent, so we're going to rewrite this in exponential form. So square root of 16 is 16 raised to 1/2. Again, you may pause the video and answer the questions and then check afterwards. Play it again to check your answers. Okay, for the second one, it's 64 raised to 1/3. The last one is 256 raised to 1/4. I hope everything is correct in your answer. Okay. Another basic concept that we need to learn, we start by understanding them by giving you some examples. Okay. Using the power rule of your index laws. Okay. 8 raised to 2/3 is the same as 8 raised to 1/3 times 2. So I separated the 2 because I would like to have a numerator 1, because if your numerator is 1, you studied it and you just learned it in the previous slides that I have shown you. Okay, so we can now rewrite this. You know how to rewrite this based from what you have just learned. So this is actually the same as 8 to 1/3 is the same as cube root of 8, and then you just write the exponent or the index outside, which is equal to 4. The cube root of 8 is 2, then 2 raised to the second power is 4. Okay, another example, 81 raised to 3/4. We're going to separate and make the index power, okay, into with a numerator of 1, which is 1/4, and then we put 3 outside. Knowing what you know from the previous slides, you can rewrite 81 to 1/4 to fourth root of 81 and multiply it and put your exponent or index outside. Fourth root of 81 is 3. 3 raised to the third power is 27. Okay. Last example, using the power rule, 32 to the fourth fifth is the same as 32 raised to 1/5, okay, times to the fourth power. Using the power rule, we know how to rewrite 32 and 1/5. This is equivalent to fifth root of 32 raised to the fourth power, and 32, the fifth root of 32 is 2. 2 raised to the fourth power is 16. So we are also evaluating it. We are not just writing it in radical or surd form. Okay. So in general, your general rule is going to be, okay, any a raised to m to the n is the same as the nth root of a times raised to the m. It's also the same as if your m is inside the radical symbol. Okay, so m can be inside or outside. And m is your exponent and n is for your radical sign. Okay, here's another example of how to write it. Okay, moving on. Let's check some of your understanding. Write in radical or surd form. Stop the video and then solve it. Okay, moving on. Here are your answers. Cube root of 27 raised to the second power. Fourth root of 16 raised to the third power. Sixth root of 64 raised to the fifth power. And fifth root of 32 raised to the second power. Now, let's extend it by evaluating the value. Third, the cube root of 27 is 3. Then square it, you have 9. Fourth root of 16 is 2. Raise 2 to the third power is 8. The sixth root of 64 is 2. Raise 2 to the fifth power, it's 32. And then fifth power of 32 is 2. Raised to the second power is 4. Okay. Another exercise. Write in index form. Okay. Again, stop the video and do it on your own, and then press play again to check if your answers are correct. Let's now check your answers. Okay. In index form, this should be written in 625 raised to the 3/4. Second one should be 125 raised to 2/3. And then the last one, 100 raised to 7/8. Okay. Now, evaluate the following problems. Again, stop the video and solve them. To continue, here are your answers. It's a cube root of 27 raised to the second power. It's 9. 64 raised to 1.5 is the same as 3 halves, so you should have 512. And remember that when you have a negative exponent, it's actually 1 over and then your equation here or your expression here down below. So it should be 1 over 27. The last one should be 1 and 1/2. I hope you got everything correct. Okay. In summary, here are the equations involving indices or your rules. Okay. Multiplication rule, you add the exponents. Division rule, you subtract the exponents. Power rule, you multiply the exponents. Now, take notice that you can only do this when your bases are the same. Okay? You multiply them when you have coefficient, but if you don't have coefficient, then you don't multiply. And then also remember, any number raised to a negative exponent, it doesn't mean that you have a negative value. Okay? It only means that your answer is less than 1. Okay? Here are your new rules. Unit fraction rule and general fraction rule. Okay? And also remember, any number or any variable raised to 0 is equal to 1. Okay? If you are still confused, please watch this video again.